Trigonometry, section 1.1. Let's begin with some basic terminology about angles and some geometry stuff. First of all, if you wanted to have line AB, you would put this double arrowed line over the letters AB. Excuse my writing there. If you want to have line segment AB, you would put a line without the arrows because it comes to an end. It's just a segment. If you want ray AB, you'd put one arrow, just one-sided arrow, not double, and the left letter would be the end point, and the right letter would be some point on this infinitely long ray. These others, here A, B is just a segment. Here A and B is a line that goes on forever. This is sort of a half line. So, what is an angle? Well, an angle is two rays. So, this could be ray AB. This could be ray AC. This could be angle. And usually you put the little angle there. BAC. It could be angle CAB. Doesn't matter which order you do these three letters, just so you put the A in the middle. And in fact, if it's not confusing, angle A is fine all by itself. Many times we'll put a little curved line there with a 1 or a 2 or a 3, so it could be angle 1 if we want to label them and show them a little easier. These angles have an initial side. Let's call this the initial side. Let's change colors. This is the initial side, we'll say. And the terminal side means we swing that initial side and go into the terminal side for the angle. Now, mathematicians have also found that in many calculations, it's good to have a positive and a negative angle, if that makes sense. So they put things in standard position. And that standard position always uses the positive x-axis as the initial side. And you swing that counterclockwise for a positive angle until you reach the terminal side. Just like we did here. But now if you go clockwise, you can reach a terminal side. This is a positive angle. This is a negative angle, clockwise. You can also get angles that are very large. Now you might say, how can it be greater than 360? Well, you can just keep going around in circles to reach a terminal side. This is still the initial side. That's still now the terminal side. And this angle, if it has the same terminal side as another angle, is called coterminal. So an angle in standard position may have an infinite number of coterminal angles. How do we measure these angles? We do degrees. We do radians. Those are the two we're going to worry about. There's also something called a gradient, just as an aside. Degrees, there are 360 degrees in a circle. For radians, there are 2 pi radians in a circle. And for gradients, there's 400 gradients. The gradient, which we're not going to study, was an attempt to make 90 degrees into 100 degrees, because everything in the metric system was based on powers of 10. So we're not going to worry about that. We're going to worry about the degrees and radians. On degrees, I guess, is what we're going to start with. 360 degrees was figured out because of the cycle of the year. At the beginning, they thought it was 360 days, not 365 and a quarter. How do you get to radians from that? Well, if this is the radius of a circle, and you take this length and measure around the circle that length, that curved length, this is then 1 radian. And if you do that and go all the way around the circle, you get the circumference. But what is the circumference? How do you figure out a circumference? Well, remember, pi is the ratio of the circumference to the diameter. So the circumference is really the diameter times pi. But the diameter is really 2 radiuses times pi. So the question of how many radiuses are in the circle, the circumference, there are 2 pi radiuses in a circle. And that's a nice thing, because these radians aren't a unit like degrees or gradients. This is just the number of radii in the circle, and that'll be helpful later on. But that's just an introduction to that. We're going to talk more about that later. Now let's do some more talking about angles. What is an acute angle? That is an angle whose measure is between, not including, 0 degrees and 90 degrees. What is a right angle? That's a measure for an angle of exactly 90 degrees. Now between is between. 0 doesn't work, and 90 degrees doesn't work for an acute angle, either of those. An obtuse angle is when the measure is between 90 degrees and 180 degrees. So 90 degrees is not obtuse, 180 is not obtuse. In fact, 180 degree angle, you can call that a straight angle if you want to. We don't use that as much. That's halfway around the circle. What are complementary angles? The measures add up to 90 degrees. So 30 degrees and 60 degrees are complementary. Anything where the measures of the angles add up to 90 degrees. That would mean both of those angles would have to be acute. I guess unless you said 90 and 0, but that's sort of an extreme case. Supplementary angles. That's the measures that add up to 180 degrees, a straight angle. Supplementary. How do you add and subtract degrees, minutes, and seconds? Well, let's see here. Remember, it takes 60 seconds to get a minute and 60 minutes to get a degree. This is just like hours and minutes and seconds. Seconds are labeled with two, it's a double quote, I guess. Minutes are labeled with a single quote, and of course degrees are the little circle for the exponent position. So how do you add these together? If you have 10 degrees, 13 minutes, do it that way, and 24 seconds, and you want to know what that is added to, say 120 degrees, 42, let's say 52 minutes, and 15 seconds. Suppose we are adding these together. Well, you add and then you carry when you get to the 60s. So this becomes 39 seconds. That doesn't get over 60, so you don't have to worry about that. This is now 65 minutes, which is 1 degree and 5 minutes. And now you've got 1, 0, and 0, so it's 131 degrees, 5 minutes, and 39 seconds. Subtracting is when you would have to borrow to do some of that. Suppose we had 120 degrees and 13 minutes and 24 seconds, and we're subtracting the 10 degrees, the 52 minutes, and the 15 seconds. Well, if you've got more minutes or seconds than the one you're subtracting from it, then you do it normally. 14 minus 5 is 9, so that would be 9 minutes. But if you borrow, this is then 119 degrees, you have to borrow 60. And 60 and 13, we should say, is 73 minutes that you're using now. So 3 minus 2 is 1, and 7 minus 5 is 2. So you needed to borrow that 1 degree, which is 60 minutes, and then subtract. So 119 minus 10 is 109, and that's what you get. Now, your calculator, hopefully you can zoom in on this, will work on these nicely. If you take the 10 degrees, above the apps button is in a different color, angle. So we can pick the degrees and the minutes from that. So 10 degrees, 13 second apps, number 2, and 24, there is not a degree mark in the angle directory. We use the double quote, alpha. So we add to that the 120 degrees, second apps 1, the 52 minutes, second apps 2, and the 15 seconds alpha plus. Now we get a decimal, 131.094167667. What if we wanted degrees, minutes, seconds? Well, just like this degrees, minutes, seconds here, we can convert that under the under the angle, second apps, there's a DMS with a little arrow to the left. That means take the number and convert it to degrees, minutes, seconds. So we're going to do number 4. So it takes the answer. Every time you do a calculation, it puts it in a variable called answer, ANS. And convert that to degrees, minutes, seconds. And there's the 131,539. So if I had a choice, I would use my calculator to add and subtract. So now let's talk about the last couple things here. Quadrantal angles. Well, that XY axis really divides the plane into quadrants. This is the first quadrant, the second quadrant, the third, and the fourth quadrant. They count those counterclockwise too. And any angle that divides this into those four quadrants is going to be a quadrantal angle. So 0 degrees, the positive x-axis, positive y is 90 degrees, the negative x-axis is the 180 degrees, the negative y-axis is 270 degrees, and then back around we get to the 360 degrees. These are called the quadrantal angles, and any multiple of them, add 360 to each. I guess even adding 90 would work, but just to make sure you land on the same spot, add 360 to those quadrantal angles. If you wanted to find a coterminal angle, to say 47 degrees, one way to look at that would be this angle, we'll say, is 47 degrees. In order to find a coterminal angle, we would start at that spot, go around the circle once, so we would add to the 47 degrees 360 degrees. So we get 7, 10, 407 degrees is a coterminal angle. We could add another 360 degrees to that to get another coterminal angle. We'd have 7, 6, 7. So 767 is also coterminal. In fact, we could take that 47 degrees and subtract 360, which is really subtracting 47 from 360 and then making your answer negative. 10 minus 7 is 3, 5 minus 4 is 1. So 313 degrees. If we went this negative 313 degrees, we would get to that same terminal side, coterminal. All of these we can find by continuing to add or subtract 360 degrees. That would take a long time to list. So the way we usually talk about all angles coterminal to 47 degrees is start with the 47 degrees and then add 360 degrees n times. Well, what if we do it once? If we do it 0 times, n would be 0. 1 time, n would be 1. Negative 1 time, n would be negative 1. So n is an element of the integers. This double strike z stands for the integers. And that's how you write all angles coterminal to a given angle. Well, we can take a look at some of the examples on page 7 from the exercises. Your assignment is not these 1.1 exercises. It's at the end of the chapter. In fact, what I've done is taken the review exercises and divided them up into, at the end of each chapter, not at the end of each section, but the review exercises at the end of each chapter, and divided those up into sets of like 25, 20, 25 problems. So your assignment will be the first 25 problems for the review at the end of chapter 1. Let's take a look at some examples, though, to give you something to go by. You may or may not, depending upon how well I've divided these up, be able to do all these problems, and sometimes the order that they give you at the end of the chapter is not exactly the order of the sections, but I think they're pretty close. So, if you wanted to find, let's do a problem. You want to find the complement and the supplement of the angle, we'll call it angle 1. Suppose it is 89 degrees. What would the complement be? Well, 89 degrees plus some angle has got to equal 90 degrees, right? So x would be the 90 minus the 89, where x is equal to 1 degree. So the complement is 1 degree. And what I'm trying to show you, I guess, is when we say you have to use 4 steps to show your work, you should be able to get 4 steps by writing down the problem when possible, writing down what they're asking for, using your equations to figure things out. Suppose they wanted the supplement. Well, remember, the supplement is the degrees, 89 degrees, plus something. That'll give you 180 degrees. So x is equal to 180 minus 89 degrees. Also, it brings up ideas like, make sure you put the degree mark when you're doing degrees. Later on, when we focus also on radians, if you don't put a degree mark, I'll assume that it's radians, perhaps incorrectly. So what is 180 minus 89? See, 10 minus 9 is 1, 17 minus 8 is 9, so x is 91 degrees. It's 1. And it's good to circle your answers or box them in. So there's an example of how you'd find the complement supplement may be asked on the test. So here's another problem, example. I've already written out what the problem asks. You don't have to write maybe everything, but this is at least 2 steps. I got half my problem done here. The other thing I need to notice is that this is a straight angle. These add together to be a straight angle, or 180 degrees. So 20x plus 10 plus the 3x plus 9 has got to equal 180. Let's see, we've got 23x plus 19 equals 180. 23x equals, what is 180 minus 19? Don't always grab that calculator. Do some of this either in your head or write it to the side. It's another step. That's 10 minus 9 is 1. 7 minus 1 is 6. 161. I'm going to divide 161 by 23. Does it go evenly? Well, let's see. I know that 20 goes in 105 times, and 20 goes into 63 times, but it's 23, right? So I don't know. We'll have to see if this comes out nice. 161 divided by 23. So say 7. 3 times 7 is 21. This is 1460. Yeah, it comes out nice. So x equals 7. So now x is 7. That is the these measures. Then if we plug in a 7, it all depends upon how they're asking this question. If x is 7, then this angle is 3 times 7, 21, plus 9 is 30 degrees. And this angle, 20 times 7, is 140 plus 10, 150 degrees, which does add up to 180 degrees. How about another? We take the hands of a clock. Suppose we have a clock, and its hands are pointing. Here's 12, 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12. So the short hand is pointing sort of in between the 1 and the 2. The long hand is pointing at the 9. And they would like the smaller angle formed by this, so they just want this angle in here. So how do you find that angle? Well, it's not as straightforward as it might sound, because 360 divided by 12 is 30 degrees, right? 360 degrees. So every 5 minutes is 30 degrees. So here's 1, 2, 3, 4. 4 times 30 is 120 degrees. But this is not a complete going from 1 to 2. This is in between. In fact, it is, if you think of the hour, at 1 o'clock, this was pointing directly at 1. And then after 3/4 of an hour, it's pointing where it is now. So I need 3/4 of 30 degrees of many times for multiplication. So this is 3 times 30 or 90 over 4. Let's see, 4 goes into 90, let's see, twice, that's 8 and 10. 4 goes into 10 twice, that's 8 and 1/2, so 22 and a half. So 120 plus 22 and a half is 142 and a half degrees. Does that make sense? Well, if this is 140, of course that's bigger than 90, that makes sense that way. The rest of this would have to be what makes up the 360, and it's at least worth looking at that and making sure this at least makes sense, and I think it does. Okay, here's another one in that first section, 128. They want us to plot this point on the XY axis. So we can do this. 4 times the square root of 3. Well, the square root of 3 is like 1.7, right? And 4 times that's 28. So 6.8. So we're looking at something out here. And then a -4. So it's someplace here. So this is that point. Right? Then they want the least positive angle. Draw a ray from the origin through that point. First, we did that, a ray. So we need to make sure. And then it says indicate with an arrow the angle in standard position had the least positive measure. Now, this would be negative, but the least positive would go all the way around counterclockwise. And then find the distance r from the origin using the distance formula. So, you guys remember the distance formula? The square root of x sub 2 minus x sub 1 quantity squared plus y sub 2 minus y sub 1 quantity squared. So one of those points is 0, 0. So we really don't have to worry about anything but 4 square roots of 3 squared and a -4 squared, which is, well, remember when you square something in parentheses, you square both things. So 4 squared is 16, and square root of 3 squared is 3. And a negative times a negative is a positive, 16. So what's 3 times 16? Well, that's 48 plus 16. This is 64. Square root of 64 is 8. Don't have to worry about positive and negative because the square root was in the problem. You only worry about positive and negative when you introduce it to try to figure things out. So that's what R is. R is 8. So 4 steps at least. Another problem on that same page, 132, a rotating tire. So we got this tire. It's got the nice spoke wheels. I guess that's a windmill. It could be a tire. 90 revolutions per minute. I'm going to call it rev per min. So I've got something to work with. How many revolutions does it make per second? And what we can do is use change this dimension here. Dimensional analysis is what they called it in the courses in physics, courses in chemistry, things like that, where you change the dimensions. What we'd like is revolutions per second. So rev per sec is what we'd like. So if I can change this revolutions per minute into revolutions per second, I'll be done. Well, I don't have to change the revolutions. I have to change the minute. So 60 seconds. Oops, I'm sorry. 1 minute is 60 seconds. The minutes cancel, and now you've got revolutions per second. So it's 90 over 60 revolutions per second. Cancel the zeros. Divide both by 3, you get 3 over 2 revolutions per second. So 1.5 revolutions per second. But all we did was dimensional analysis, a chemistry thing, change the units. You should be able to do the first ones from section 1.1 at the end of the chapter for the first part of your assignment.